walk-in freezer, 25 degrees. There's our floor. There's our intelligent unit. This apparently is a newer system installed by somebody else, not me. Hold on, let's get a light back here. Looks like the ceiling's leaking mashed potatoes. Oh no, that's just spray foam and lots and lots of foam tape. Damn. I thought I was good at insulation, but man, whoever did this is fucking great at installing insulation, man. That is amazing. It's got to be what do you think, like 3/4 roll of foam tape? Anyway, that's not why we're here. We're here because it's 36 degrees in here. Let's see what our box settings are. Set point is 0. Refrigerant 448. Alright, so honestly not much to see down here. Fans are going. It is apparently calling for cooling. Actually, you know what? I almost forgot. Let's see what our EXV is set to. Go to monitor. I just want to see if our EXV is open. Position 255, suction pressure is 13, suction temperature, coil temperature is 38, huh? Alright, well, they say it's programmed for 448, however, that's not always the case. It could be programmed over there as 448, but that may not be what's actually in the box, so yeah, let's jump up on the roof and see what's going on with the condenser. I believe that's our walk-in cooler. This I'm 93.2% sure is our freezer. I didn't do that, I found it this way. But let's pull that, oh, I don't even have to pull the cover. It's already open. Look at that. It's not like this is outside or nothing and the wind would blow it open and then rain would get all over it. Look at that, that's pretty sweet, huh? Alright, let me grab my meter, I'll swing over to that side and we'll start checking some stuff out. All right. Oh, this has got one of these DTC valves. Yeah, interesting. Been a while since I've seen one of those in the wild. I like these bone units. These are pretty good unit for the most part. It's got its quirks. It's got its little things that I don't really care for, but you know, whatever. Could be worse. It could be a train unit, right? Right? Am I right, all you train guys out there? You know I'm right. You know what really makes me mad though? So nowhere downstairs is it written down what refrigerant is in this unit, right? So, and I just had this issue the other day. These are all the refrigerants that it can take. Boom, right? Nothing written down over here, which would be cool, you know, somebody just take a paint marker, jot it down, or like what I like to do is, you know, write it inside the cabinet somewhere here. You know, so the sun doesn't get it, rain doesn't get it. I got nothing over here. Walk-in cooler short cycling. I'm sure that's set up and running optimally. Oh yeah, nothing written down over here. Yeah, so the only thing I have to go on is they programmed the evap for 448A, which the other system I ran into the other day is doing all sorts of funky stuff, and I'm pretty sure it's actually got 404 in it, but the system is programmed for 448A, so I quoted to pull the charge and then charge it up with 404 and just go from there. But yeah, let me get my meter out and start doing some stuff. All right, I'll bring you back in a minute. Right here is our pressure switch. I got 210 volts. That means my low pressure switch is open. So I'm hooked up, and I'm not sure how well you guys can see this. So my low side's at, 13 PSI. High side is at 217, which would be about a 92 degree condensing temperature, but it's almost like we're pumped down. But we shouldn't be pumped down because the electronic expansion valve was, what was it, at 255 steps, and our set point is 0, and our current box temp is 38 with a 2 degree differential. So we shouldn't be pumped down at all. I mean, if anything, we should be equalized right now. I'm back down in the box trying to figure out why the upstairs unit is essentially pumped down. And I got to noticing, look at this amazing drain. Awesome. Shark bites, pecks. Giant chunks of ice. I'm guessing they had a drain issue. So yeah, awesome. Alright, so two things I wanted to point out here. Our electronic expansion valve is opened up all the way, 255 steps, but also our board voltage is only 23 volts. Not sure how well you can see that, if you can see it at all, but our transformer is tapped for 240. So I'm going to shut this off real quick and switch that around. And that's after we switched the transformer taps from 240 to 208. So the board now has 100% proper voltage. Let's see if anything changes. So this is a little hard to show you guys, so I'll just tell you what I did. So right over here is our electronic expansion valve. It's hard to show you because I have a wall right here. You know, there's not a lot of space. And so I was just checking the electronic expansion valve because I suspect it's got issues. According to the manual, boom, right there, you're supposed to check resistance at the pins on the valve itself, right up there. But I can't really get to that now, can I? So, yeah. So all I did was unplugged it, and I checked it over here at the Molex, where it goes into the control board, and I got 137 ohms. It says it should be 150 at 75 degrees, so since we're at about 40 degrees, I'm just going to assume that our windings in the electronic expansion valve are okay. But we're essentially still in a pump down state at our condenser, and I don't know why. But anyway, I checked the windings of the electronic expansion valve. I even pulled the little Molex off the top of the electronic expansion valve stator just to make sure that it was positioned properly. After talking to tech support, which by tech support I mean Chris Stevens from HVACR Videos. He's amazing. Shout out to Chris. You're the man, Chris. I do appreciate all your assistance. Which, by the way, if you guys ever do want to call Chris, you have to have one of these fancy Bluetooth earpieces, or he won't answer the phone. It's just simple as that. So yeah, I went through. Windings are good. They're 137 ohms. The manual states that they should be 150 ohms. I apologize for the wind, guys. I can't control it. I tried to mentally control the wind before, but it doesn't work. Anyway, it's just stuck. It's just stuck. All right, guys, it's just stuck. That's just the way it is. So with that being said, I got to get on the horn with some supply houses. No, that's not where I'm at, by the way. That's the restaurant across the street. But yeah, so I got to get in the horn to some supply houses, see if I can open one up and get an electronic expansion valve. So if I can and when I can, I will bring you guys back, all right? So hang tight. All right, guys, we are back. It is Monday. We're back on this walk-in freezer deal. the electronic expansion valve is stuck shut. I did come back here Saturday, the day after I was here for the initial diagnosis. I came back Saturday and attempted to do the job, but got rained out. Even though I had a tent and all the other fancy shit, I still got rained out. Now Saturday, I got the charge recovered. Right now, I was able to put a holding charge, just some nitrogen, back into the system before I left Saturday, so there's no refrigerant in the system right now. I am going to change the dryer again. I did change it before. When I was here Saturday, that was the last thing I was able to do, was change the dryer. I'm going to put a little bit of an oversized dryer in there. Plus, I don't like the piping that I was able to do on the fly in the moment, seconds before rain started pouring down, and hail, by the way. So yeah, I'm going to do the dryer, make it look nice, get my manifold hooked up. We're going to be using our True Blue hoses. We're going to do the whole 9 yards today, guys. Got our nitrogen flowing. New dryer's piped in. I opted to just replace this entire elbow. Quick side note, because when I was here Saturday, the thunderstorm hit. I had a tent over me, so I kind of rushed this filter dryer install. And honestly, I didn't like it. It held pressure. Don't get me wrong, it would have worked just fine. But it looks like garbage, and honestly, I don't want to put my name on this. It was a rush job in a very unique situation. Lightning, thunder, rain pouring down. I had to get it in. I was trying to get the job done, but I just couldn't do it. And like I said, it did hold pressure. It just looks like straight garbage, so I didn't want to use it. So I'm not going to. So I just cut it out, and this will be no charge to the customer. This is just something that I want to do before I put my name on it, all right? And to my boss, if you're watching, I owe you a filter dryer. How about that? Let me give you a quick preview of what I'm about to do, because there's no way I'm going to be able to film anything because I'm right tight up against this corner. So let's slide over here. Got my old valve cut out, and then I'm just going to unbraze these nubs and then kind of manipulate this distributor, fold it over a little bit, and then braze in the new valve body, and then we'll put on the solenoid in a minute. But in my opinion, preparation to braze is almost more important, if not as important, as the brazing process itself. You know, I got all my wiring out of the way. I got the control board moved out of the way. It's hanging there by some wires. It's safe. I'm going to be aware of my surroundings as I'm brazing, of course. And over here, this pile of nonsense. Essentially everything I think that I'm gonna need while I'm brazing, I have it within arm's reach. I have some water, I have a fire extinguisher outside the view of the camera, of course. I got my hot block, which I'll put on the new valve. Everything I need, I'm ready to go. Okay, I'm prepared to braze. And that's very important. You don't want to get halfway through brazing and then stop and then put more heat to it. You want to get on it and get done. All right, so that's exactly what I'm going to do. I'm going to braze this in place, and I'll show you the outcome when I'm done. Here we are. The electronic valve body, anyway, is brazed in place. And braze joints came out pretty good. In hindsight, I wish I would have took a wire wheel and cleaned up the old braze, the old solder, before I sort of reused it on the new joint. I did put new silver in there, but I always find it better if you just take a wire wheel and clean up that old joint before you do it, and I didn't do it this time. But I was flowing nitrogen, so we should be all set. I got my screen in there as well, so I'm going to run up on the roof, crank the nitrogen regulator up to purge, and make sure we're actually sealed up. I think while this is pulling down, it's a good time to start getting some stuff cleaned up and organized around here. I just started the charging process. I've added 12 pounds so far. The receiver is 6.8 liters, which comes out to be about 14.9 pounds. So I did about 80% of that, which comes out to be about 12 pounds or so. Now, right now, you'll notice we're all frosted up. I literally just turned this thing on, so my evap downstairs isn't cold enough yet, so my fans downstairs aren't running, so this is normal. I got no worries about this. Tried getting my camera turned on a few seconds ago, but I was trying to highlight the rise in pressures that I was seeing. Line set hasn't really been hit with all my superheat yet, but my pressures went up because my fans downstairs are finally turning on. So give it a second. Our pressures will equalize to where they should be. It's probably, I don't know, about 60 degrees out here, 60, 65-ish. So my head pressure will probably be about 85, 90 degrees. So we're looking pretty good. My box temperature right now is about 50, 55 degrees. This box has been down for 2-3 days now. So our low side pressure will be a little abnormal for the time being. But like I said, that is to be expected in this situation. It's getting there. So guys, I was here a couple days ago fixing this walk-in freezer unit, right? Now, if you guys have seen this video, it was kind of a little bit of a debacle. It was an emergency and I got rained out and I came back and needed a new electronic expansion valve, right? So a couple days later, I got a call on this, the walk-in cooler is getting warm. So I'm here today working on that, right? And then I noticed this mess right here. Obviously, it's not supposed to have all this ice on here. So what I found is I went downstairs, put it in service mode real quick, watched the electronic valve steps down to 0, and this continued to run. In test mode, what I found is as the control board was opening and closing the valve, my voltage was, initially it was way too low. I was getting like 24 to 25 volts from the board going to the electronic expansion valve, right? Keep in mind though, I do have 26 volts going to the control board from my transformer, which is absolutely 100% correct. Now there's a capacitor on the control board that helps drive that electronic expansion valve open and close, apparently. So anyway, in test mode, I watched it go around 3 or 4 times. First time was like 24, 25 volts, second time 26, third time 24, 25, and then like the last one was real low, like 4 volts. And according to tech support, just some food for thought, I'm supposed to have 37 volts to open and close that valve. So apparently my control board has gone bad. Yeah, I've been on the phone all morning trying to find one of those. It's almost like they're just non-existent in the US. Yeah, you guys probably can't see that, but right now I'm just entering service mode. You go to test mode, enter the code all 9s, 99999, and now we're slowly entering service mode. And what this will do is it will go through and energize all the relays. It will also send power from this Molex plug to my electronic expansion valve, and that's what I need to monitor. Actually, while we wait for that to happen, let's just verify proper voltage down here. We have 27 volts going into the control board. Right down here where it says 24 volts, 24 volt return. Bottom of the camera right here. Defrost relay. We don't care about that right now. We're waiting till it gets around to our electronic expansion valve relay. That's what we want to see. Fan relay. Nah, I hate that fan relay. It's super annoying. alarm relay, also don't care about that. Liquid line solenoid relay, we don't have a liquid line solenoid, of course. Our electronic valve acts as our solenoid in this system, so it must be the next one. I guess I was wrong. I don't know when it's going to be. It might not even be in here. Who knows? 23 volts. So yeah, I should be getting 20, or I should be getting 37 instead of 23. Alright, let's shut this down, change this board. Alright guys, new board is in place. Interesting thing is, I just heard that electronic valve shut and the condensing unit upstairs just powered down. So that makes me super excited. We just got to configure the new board. Eastern daylight saving time, we'll say yes for now. Date, time. Low temp electric, definitely. We're gonna go on demand. We got 404. Suction temperature, we want suction pressure. So we're pumped down at 12. I'm not gonna mess with that too much, that seems fine. Like I said earlier in the truck, I usually keep it around 5 to 8, so 12 isn't bad. I'm gonna leave this right here, so once our electronic valve opens up, we can watch our suction pressure rise, and the condenser is maybe 4 foot above me right now, so I can hear it start. There's our suction pressure rising. It should hit about 25 to 30, I think our cut-in pressure is. So what I'm going to do is I'm going to run upstairs, just verify that the compressor is running. 900% sure it is, because we're at 28 PSI. And then I'm going to come back down here, put it in service mode, let it pump down, and verify that the condenser does pump down and shut off. Alright, so let's go for a walk. Here's our condenser. It's running. It's froze up. Because it's been running non-stop for a very, very long time. So, one thing I'm going to do while I'm here is defrost this. Shut it off and let it defrost for a little while. Now let's go back downstairs, put it in service mode, and we'll make sure it pumps down and shuts off. Alright, we're in service mode now. This thing's got some weird little quirks. Like, one of them is the extended amount of time that it takes to get into service mode. Box temp, set point differential. I'm going to change that to 3. I just like 3 better. All right, let's run upstairs real quick, make sure we are off. All right, we are off. Yes, we are still frosted up. I'm going to just let this sit here for a little while. Let some of that ice melt off there. All right, so hopefully that's the last I see of this unit for quite some time. Now, one of the things I didn't get on film in the initial part of the service call was when I condemned the electronic expansion valve on this unit, I did check for voltage going from that board into the electronic expansion valve cable, and I did get 37 volts, but I didn't get it on film. So I'm sure a lot of you guys are like, well, you know, the electronic valve probably wasn't bad. Based on my findings, it was. Now, did that board crap out after I changed that expansion valve? There was a storm that moved through the day I was here. Maybe. I don't know. Did that have something to do with it? Maybe. I don't know. I'm going to tell you the story as I pace back and forth on the roof. The other thing is that evap coil is tied into this condenser. Now, does that make a huge difference? Maybe. I'm not sure. I know factory, they want it wired on its own circuit so that the surging of the compressor, the locked rotor amps on startup, doesn't affect the low voltage going into the control board, since it's tied into the same circuit. Does that make a huge difference? I don't know. I'm not an engineer. But I have heard through the grapevine that those little things can have some wonky effects on these. Again, I don't know for sure. So, I don't know. But I do know that initially I did get 37 volts to my expansion valve, and it wasn't moving. It wasn't opening, it wasn't closing. And I changed it, and then it wouldn't drive open or shut with the board. So, I mean, honestly, it could have been both. I could have just had a bad board that at that very instant that I was checking voltage, I got 37 volts, and then the rest of the time it wasn't. That electronic expansion valve could have been good. Like I said, maybe that one time I tested, I got 37 volts, whereas the other times I was only getting 23, 26, you know? But the point of this matter is we got them up and running. They got a new valve, they got a new board, and I learned quite a few lessons along the way. And for all those out there wondering, I mean, we did make multiple visits to this. Obviously, I'm not going to be charging the customer for every single time that I was here for all this nonsense. I mean, don't worry about the billing side of this, guys. Just look at this video for what it is. A little bit of educational material showing you the steps that I went through and the horrifying nightmare that I lived through. All right, guys. That's all for today, guys. I'm out of here. There, parting shot of a fancy York unit. Enjoy.